Alright guys, today's goal: the learner will understand linear and quadratic functions and modeling. So, what you'll learn about polynomial functions, linear functions and their graphs, average rate of change, linear correlation and modeling. See, that's what we're talking about with the modeling. You'll see what we mean by that. Quadratic functions and their graphs, and applications of quadratic functions. Okay? Many businesses and economic problems are modeled by the linear function. Quadratic and higher degree polynomial functions are used to model some manufacturing applications. A polynomial function. Let n be non-negative integer, so the exponent cannot be a negative integer. And let a sub 0, a sub 1, a sub 2, a sub n minus 1, a sub n be real numbers where a is not 0, where a sub n is not 0. The function given by f of x equals the following is a polynomial function of degree n. So, what they mean by, and with a lead coefficient of a sub n. So, for example, there is a polynomial function. I should say f of x equals. What is the degree? 4, because that's the highest exponent. What's the lead coefficient? What's the number attached to the degree of 4? 3. So the lead coefficient was 3. Okay? You're used to seeing a from ax squared plus bx plus c. Alright. Polynomial functions of no and low degree. A zero function, just the number 0. A constant function, f of x equals a when it's not 0, so like f of x equals 2. A linear function, any linear equation. F of x equals 3x minus 1. A quadratic function, any quadratic, so negative 3x squared minus 4x plus 8. F of x equals that. Okay? There's some examples. Write an equation of a linear function such that f of negative 1 equals 2 and f of 2 equals 3. So, remember what this means. You have 2 points, negative 1 comma 2 and 2 comma 3. That's what these are telling us. X is negative 1, y is 2. X is 2, y is 3. How do you find the slope? Because you need to get this. Or, I should say, we need to get this. F of x equals mx plus b. So, slope. y2 minus y1 over x2 minus x1. 3 minus 2, 1. 2 minus negative 1, 3. So our slope is 1/3. Now just pick a point to plug into this. So watch. I'm going to pick, this is my x, this is my f of x. Substitute it in. Fill in everything we know into this equation. So you get 2 equals 1/3 times negative 1 plus b. Two equals negative 1/3 plus b. Add the 1/3 over. That's going to be 6/3, so you get b equals 7/3. So let's finish our equation now. F of x equals 1/3 x plus 7/3. Okay? Let's see if we did this right. Oh, see, they used point slope form. So here's another equation. But did they end up with the same thing? Yes. So here's another way of doing the same thing. So that's good. Okay? Rate of change. So it says the average rate of change of a function y equals f of x between x equals a and x equals b. A cannot equal b because there's no change if they equal each other. So if you look at this, this is the y values divided by the x values. So that's the slope for the linear equation. That's the rate of change. Okay? It's another thing that slope is called. Constant rate of change theorem. It says a function defined on all real numbers is a linear function if and only if it has a constant non-zero average rate of change between any 2 points on its graph. Okay, so yes, you can have a linear equation with a slope of 0, but is not a constant rate of change because it's not changing. Okay? So outside of that, though, it has to have the exact same slope throughout the entire line. Otherwise, it's not a line. So that's why it's called the constant rate of change. Characterizing the nature of a linear function. Verbal, algebraic, graphical, analytical. So verbal, the polynomial is a degree of 1. Algebraic means there's the standard form. Graphical, the slant line with slope m and y-intercept of b. Remember, m is the slope, b is the y-intercept. Functions with constant non-zero rate of change. F is increasing if m is greater than 0. F is decreasing if m is less than 0. Initial value of function, when x is 0, you get the b value. That's the y-intercept. So this is stuff we should already know, guys. Alright, properties of the correlation coefficient of R. Okay, we'll talk about, I will be going through in class how to do this with your calculators. Okay? But, the correlation coefficient. The closer to -1 it is, it's a very strong linear relationship. It's just got a negative slope. Meaning as x increases, y decreases. The closer to +1 it is, it's a strong positive. As x increases, y increases. If it gets close to 0, that means there's 0 linear relationship. We cannot use it to predict, okay? So I'll help you guys with the calculators to figure out how to find this, though. So here's some examples. If I were to draw a line, the line of best fit it's called in statistics. That was not very straight, but the line of best fit through here. See how as x is increasing, y is increasing, and a lot of those points are really, really close to the line. Now, I could still kind of draw a line of best fit here, but the points get further away. That's weak. So this would be, R would be approximately 1 here. R would be approximately like probably 0.6 to 0.7. Here it would be approximately 0. And then vice versa. This is a really, really strong negative relationship because all those points are really close. This is slightly weaker, but still somewhat usable for predictions. Okay? So that's what they mean by correlation. If you're not sure on this, ask questions in class, and we will cover it, I promise. Regression analysis. Okay, so this is kind of what we're going to have to go over in class again. It says, enter and plot the data on a scatter plot. Find the regression model. What they mean by it, we'll go over what they mean by that. That fits the problem of the situation. Superimpose the graph of the regression. So draw the line on the model like I did on those other ones, that line of best fit. Use the regression model to make predictions called for the problem. Okay, so again, this is something we're going to go over in class. I promise you this will make sense. Alright, back to transformations. Example for transforming the squaring function. Okay, describe how you transform f of x equals x squared into the graph of f of x equals 2 times the quantity x minus 2 squared plus 3. Guys, press pause. Knock this out. I know you got this. Okay, so hopefully you did. So I know it was shifted, it was translated right 2 and up 3 units and a vertical stretch by a factor of 2. Because that 2 is outside the parentheses. If it was inside the squared parentheses, it'd be a it would have been a horizontal shrink by a factor of 1/2. Okay? There we go. Vertical stretch by the factor of 2, translating in 2 units right, 3 units up. And that was what the graph would look like. So we got good to go. Here's a little bit of review from Algebra 1 and Algebra 2. If a is greater than 0, the parabola opens up. If a is less than 0, it opens down. A is positive up, a is negative down. This is, remember, now here's some more review. It's standard form, vertex form. The vertex is h comma k. Not so sure you really need this one, but this is what you really need to know. So if you're given standard form, these two are very good. This gets you the x-coordinate of the vertex. This right here is the one you need to remember. Hopefully you do, okay? So use the vertex form of the quadratic function to find the vertex and axis of the graph. Rewrite the equation in vertex form. All right. So the axis of symmetry, I believe, is what that should say, because the x-coordinate of the vertex is also the axis of symmetry. But, so remember the equation I said we needed to remember here, guys. X equals negative b over 2a. So negative 8 over 2 times 2, you get 4. Now, yeah, you could use that other equation, but I've never used that, because how else can you get the y-coordinate of the vertex? Oh, hold on. Hopefully you were thinking this. It's not 4. What's 8 divided by 4? 2. Hopefully you were thinking this, though. You just plug it in. Four, or 2 squared is 4 times 2 is 8. 8 times 2, so negative 8 minus, or plus 11, 3. So you now have the vertex of 2 comma 3, and I know that a equals 2. So if I go to rewrite this, and the axis of symmetry, x equals 2. If I go to write this in vertex form, f of x equals 2 times x minus 2 squared plus 3. So let's see. That's what we got. The equation of the axis, x equals 2. Okay? Let's try another one. Characterization, the nature of the quadratic function. Variable, the polynomial is a degree of 2, so anything squared. Here's the two main algebraic ways. And then for graphical, you get the parabola with the vertex h comma k, the axis of symmetry, x equals h. If it's positive, it opens up. A is negative down. The y-intercept is c. And the x-intercepts are the quadratic formula. Okay? Alright. So let's apply it. Okay? It says the height s and the vertical velocity v of an object in free fall are given by s of t equals, so there's the equations, where t is the time in seconds, gravity is approximately 32 feet per second squared, which is 9.8 meters per second squared, is the acceleration due to gravity. V naught is the initial velocity of the object, and S naught is the initial height. These are things where you're going to need to know, so remember these. Write these down, have these to be able to reference for homework. I gave these to you on the first test already, but have these ready. Okay? See you guys tomorrow.